Hi, this is Scott. I really appreciate our sponsors because they make the show possible. Today's show is sponsored by Developer Express. Become a UI superhero with Dev Express controls and libraries. Deliver elegant .NET solutions that address customer needs today. By leveraging your existing knowledge, you can build next-generation touch-enabled solutions for tomorrow. You can download your free 30-day trial at dx.hanselminutes.com. That's dx.hanselminutes.com.
From hanselminutes.com, it's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman. This is Lawrence Ryan announcing show number 452. In this episode, Scott talks with freelance programmer, game designer, and creator of the JSIL project, Katelyn Gadd.
Hi, this is Scott Hanselman. This is another episode of Hansel Minutes. Today, I'm talking with Katelyn Gadd, who is the creator of JSIL. It's a compiler that transforms .NET applications from their native format into actual JavaScript. It's absolutely amazing. Thanks for talking to me today.
Hi, yeah, it's great to talk with you.
So I have to admit, even before I put like two and two together and figured out that you were JSIL, I was already a fan because I have one of your games, a scapegoat, pinned in my browser toolbar. This is like a true story.
Nice. I'm glad people enjoyed that. The response was kind of difficult to gauge at times, but when I looked at the actual bandwidth stats, it was obvious a lot of people had been playing it. And it was cool to see like feedback and bug reports from people on Linux and Mac who hadn't been able to play the game before.
Mm-hmm. Yeah, it was, honestly, when I kind of stumbled upon it, the play on words got me there. It's a great name. Then I'm like, oh, well, this is a cute technology demo. And then again, forgive me for being dismissive because I'm dismissive based on the name and then the technology. And then I'm like, oh my goodness, this is like, it's like Prince of Persia with a goat and there's all this stuff and it's a pretty deep game. There's a lot going on.
Yeah, the creator of the actual core game, Ian Stocker, is a really talented game designer, and he's also a self-taught programmer. It's been a pleasure working with him on both of those games. So it was kind of great to have the opportunity to port that and one of his other games actually to the browser, because having real-world test cases for a technology like this is incredibly valuable. It kind of keeps you grounded in solving real problems for real people.
Yeah, totally. And you said both of these games referring now that you have a scapegoat too.
So yes, I did a lot on Scapegoat 2. I was on there from the beginning, but I also ported one of his previous games before Scapegoat called Soulcaster, and we put that up on Newgrounds, and it had a really good response. We were one of their first HTML5 games. Mm-hmm.
Yeah, so people can see these at jsil.org, and you can play Scapegoat and Soulcaster and some other kind of cool platformer samples that are all up there.
Yep.
Okay, so JSIL literally you start at the IL level, you read that out, and you emit a similar kind of an IL. You're not emitting idiomatic JavaScript, I assume.
So that's kind of an interesting topic. Essentially, I take the output of your build process. So some of it's IL, but I also read any images that XNA might have produced. I read your audio files. If you have resource files, I read those in so you can have localized resources working. Mm-hmm. And it actually originally did attempt to generate idiomatic JavaScript, but over time it becomes kind of obvious that if you want to support everything, you can't do that. It's sort of the same dilemma that Emscripten has when it's translating native code to JavaScript. Emscripten is essentially a native code compiler for JavaScript that's used for things like Unity and Unreal Engine. Eventually you kind of just have to go, JavaScript is just my way of talking to the processor. I'm going to do what I have to. So at this point, JSIL kind of produces a halfway point. The variables all have appropriate names. Methods all have appropriate names. There's a very clear, concise representation of all of your types and method signatures, but it also contains a lot of sort of special magic to encode things that the JavaScript runtime needs to know, or information to support things like reflection at runtime.
Mm-hmm. So this isn't something that you're going to want to edit after the fact. You're not going to want to massage this code afterwards.
You can certainly do it if you want to, but I highly don't recommend it. It's sort of an option for debugging and for kind of last resort things where you just can't get the compiler to do what you want. I prefer actually just have you put the JavaScript you want in there. There are very simple backdoors to let you go, I just want you to run this JavaScript. I want to be very specific about what I want you to do.
Mm-hmm. And these are ignorant questions, so forgive me. But when people who are thinking about something like this, and then they're trying to fit it into their larger worldview of JavaScript, there are kind of these transforming languages, these like CoffeeScript and TypeScript that kind of go laterally from some language to mostly idiomatic JavaScript. And then there are this other class of kind of like, would you say it's a true compiler? That it's
It certainly started out as something much simpler. It was literally a fork of just a decompiler where I said, I'm going to take C# and just kind of pull the types out and it'll be JavaScript. That was the prototype. At this point, it is a true compiler in the same sense that I would call Emscripten a true compiler. It's actually very difficult to figure out how to categorize these projects because they fit into a very weird spot. At this point, Emscripten, for example, is literally just a backend for Clang and other LLVM compilers. It has ceased being its own application. And JSIL sort of occupies a similar niche. Like at some point, it will probably have Visual Studio integration, and at that point, the actual executable kind of disappears. It's interesting to view it as it's a compiler, but the code that goes into it is more of a sort of computer massaged representation of what you actually wrote. As if you were taking like the output of a painting program or a screenshot of a 3D model instead of the actual model and feeding that through some sort of tool.
Mm-hmm. So this is what I think people are kind of, like, as you said, they're trying to find a way to refer to this thing. It's not a cross compiler. It's a source to source compiler. It's a transpiler of sorts.
Cross compiler and transpiler, I think, are both pretty accurate. Source to source is a little fuzzy since I'm not actually reading your source. That allows me to support F# or VB.NET and things like that. But if you view IL as the source, which you can, there's a decompiler and recompiler that comes in the SDK. It's a perfectly reasonable textual language. But it's kind of a fuzzy distinction. Yeah,
that is, isn't it? Because, even C# itself doesn't go into native code, mostly.
Right.
It's almost like abstract syntax tree to source compiler.
Yeah, absolutely. And eventually these compilers start to very strongly resemble what you get in .NET or in the JVM, where in both cases you essentially have this sort of massaged, semi-optimized, semi-compiled input, and then the runtime kind of figures out what to do with the rest of it. And just in this case, the runtime happens to be JavaScript code that runs in your browser, instead of being a native runtime with its own JIT and everything. Mm-hmm.
Now, with Emscripten, they go, if I understand correctly, from C or C++ to this LLVM, low-level virtual machine, rather. Mm-hmm. And then from there to JavaScript. Do you have an intermediary format as well?
I sort of do. I have an abstract syntax tree that's rather sophisticated. And at some point I will probably move to an intermediate format model like LLVM, just because it simplifies a lot of things. It's one of those lessons that you would learn in school if you studied computer science, but since I didn't, I've kind of had to learn compiler theory ad hoc.
Really? Wow. So that's another interesting question, because this seems like a very computer sciencey thing. This seems like a project that like maybe someone would do as their PhD thesis. And you're saying you don't have a formal background in computer science?
No. It was purely something where I've been immersed in the XNA development community for a long time and the indie scene before that. And I just watched a lot of people building games with XNA and got frustrated seeing that their freedom was being constrained. They were losing control over their destiny. And for over a year, I was just kind of thinking there really should be a way to do something about this. I wonder if there's something I can use. So the impetus to do this was just seeing that decompiler and going, I bet I could use this to solve that problem. I should do it. It was just purely motivated by solving a problem, and I just kind of focused on test cases and fixing test cases and incrementally learned most of what I needed to while I went along. One of the dirty secrets of compiler authoring, I would say, is that you can actually just get pretty far by cheating. You don't actually have to know how everything works. You pay for it eventually, but
it does sound like even some of the world's great compilers, have something in the source where it's like, I'm sorry that you had to see this.
Yeah. I feel like that's pretty common. And eventually you get rid of that stuff. But your customers don't necessarily care as long as the app works.
What was the first thing that you got? Like, what was the moment where you got it to the point where, like, I don't know, maybe you drew a circle or something, or you got a resource and you just like raised your hands in the air and you're like, yes. What was that moment?
It was probably one of two things. One of my first real-world test cases was a little ray tracer sample that's floating around on the internet that was sort of like, here's how you build a ray tracer in C#. And it used Windows forms and a bunch of gross stuff, but when I had that working and it was producing the correct results and it ran reasonably fast, that was sort of like, okay, like I did this, I didn't have to modify the code of this example at all, it just worked. That kind of at least proved to me like a good portion of this is possible. I feel confident that if I keep working on it, I'll know eventually where the end lies. And then from that, the second milestone was probably I took one of the XNA samples, didn't make any changes, and eventually had that just working out of the box. And at that point, I was like, okay, this is possible. I can probably solve everything if I have enough time. I don't have to compromise, or more importantly, I don't have to tell people you need to rewrite everything from scratch, or you have to build for this, like, in the first place. Like, you can take what you've built and do something with it. And that was actually the most compelling part of it, is just going, not only does this work, but it's empowering to people instead of me, like, forcing them to decide to do it up front.
Mm-hmm. So I went up to your demos and went kind of laterally within the carousel here and see a ray tracer. And when I look at the source C# for this kind of like the hello world ray tracer, it's about 400 lines, maybe a little less minus comments. It has a using statement in there that says JSIL.meta.
Yes.
What is that in there for? And why does my C# need to know about JSIL to get involved?
So that's actually wholly optional, and that's basically there because it's from an earlier stage of the project. Essentially, JSIL has this layer of information you can provide to the compiler that tells it what to do with your code when converting it to JavaScript. So the original application is unaffected by it, but it allows you to say, okay, I want you to just replace this function with some JavaScript I've written. I want you to not translate this function. I want you to do some special performance optimizations on it, that sort of thing. So in this case, that's inline directly in the code. You can see the attributes in one or two places. In practice, for newer applications, you don't have to touch the code. There's a way to create a new assembly, a new project that contains all of the compiler information, and then the compiler pulls that in with your application and layers it over. So you can essentially have a third-party developer who doesn't even necessarily have the source code to your app, just maintain the compiler configuration and the browser-specific code, and combine them together to actually get your output.
That's really interesting. Now, we're on a podcast, so people can't see this, but I would encourage folks to try to follow along. I thought that this was particularly clever because if you think about, there's the truly abstract, not painting to the screen aspects of a game. But then there's also things like, debug out. And in this little example, you have some debug out where, on a .NET person would just say debug.writeLine or trace.writeLine. With the attribute technique, you were able to say JS replacement, and I want to put not the debug out here because there is no debug out. I want to put it into this DOM element. But then you're saying now that could be even done as a separate plugin, almost an aspect-oriented, kind of an IL weaving.
Yes, that's exactly what happens. And in practice, I think almost all of this scaffolding here could go away. I just haven't updated the example.
Sure. But
it's very easy to incrementally go through and make these adjustments where you can get an application up and running at a basic level and then kind of incrementally go in and figure out, how do I want to adjust this? Do I want to pull this logic into JavaScript? Do I want to re-architect my application so it will behave better? Like in a couple of cases, you go, this works out of the box, but I do actually want to go in and refactor it a bit so that the browser is able to handle it better. Like the main execution change I made to this ray tracer example is it had a main loop that was synchronous. I changed it to instead just issue a callback per scan line, and you see its set timeout function in there. That was the one change I made because it made it much easier to go, okay, now I'm not going to hang the browser. I'm going to be a good browser citizen. I can make it render slowly if I want to kind of show the progress, that sort of thing.
And the resulting in this, even in this very early example here, the resulting is, I would say it's probably 70-80% very readable. There's some spots where you're setting up your functions and you're kind of building your fields, but it's not the mess I thought it would be. You know what I mean? It's actually fairly readable. It's really neat.
Yeah, and the vast majority of the noise in these code files can actually be turned off. It's mostly from optimizations.
Mm-hmm.
So it's quite possible that in the future there will essentially be a debug mode for if you just want some really nice idiomatic JavaScript. It's the sort of thing that gets difficult to maintain as a balance as a project like this goes on. But it's definitely possible for a compiler like this to produce really high quality code because .NET gives you so much of the information you need.
Mm-hmm. Well, it seems like there are really competing ends here.
Mm-hmm.
Like you just said a moment ago that, well, I could update the sample to use the new stuff. But my initial reaction was like, no, don't. That's a great learning experience. Mm-hmm. I could teach this to someone in a game development class or a JavaScript class or a C# class. 3 different kinds of classes, I would want to show that kind of stuff. That's a different competing end to I want my app to run as fast as possible in modern browsers.
Right. Yeah, and at this point, I kind of had gotten to the point where it was producing functional idiomatic code with the exception of kind of always finding corner cases the compiler doesn't support. And then the priority sort of became, okay, if this is going to work for real-world games and applications, it has to be fast enough. Mm-hmm. Like, it's never going to be as fast as C code compiled to native or compiled to Emscripten, but my goal was to kind of at least approach sort of the performance profile of .NET. Like, you don't want to have weird landmines you hit where you go, oh, now I've got to rewrite my whole application. So a lot of this work has been that, making it consistent, making it work well across all the browsers. And thankfully, that's all kind of done incrementally. I can layer that all on top, so it's still possible to turn it off or remove some of it or adjust how those things work.
Mm-hmm. And another kind of looks like an early example, JSIL version 0.79. What version is it on now?
That's basically the current version number. Okay. To be honest, there's not a very aggressive versioning scheme here. I just bump the number occasionally.
That's cool. There's Semver, and then there's like, that felt like a version. Looking at the WebGL example, this one's a lot more intense in the sense of I've just gone from kind of a static ray tracer to now I'm really doing 3D. This, I felt, was when it really started getting interesting because then the question is, how are you translating between C# types that we use in XA and that we know about in canvases and things, and how are you translating when something exists in a one-to-one or near one-to-one relationship in JavaScript, and then other times when that type doesn't exist, we're going to have to make that from scratch.
Yeah, it's a difficult balance, and every compiler that does this actually kind of takes a different approach. Mm-hmm. The approach here, like the WebGL example, is actually a port of a JavaScript tutorial for learning WebGL. My attempt was just to go, I'm going to show how you can express these same patterns in C#, using the same lessons, not having to adopt a bunch of new stuff or a special set of libraries. So the approach here was essentially write C# that is as obvious and idiomatic as possible, even though WebGL code is obviously not going to run outside of the browser. Mm-hmm. And then essentially just sort of write the most obvious thing that seemed like it should work and then make the compiler able to support it. So in this case, to interact with the WebGL API in the browser, it just uses dynamic. Mm-hmm. Dynamic is a great springboard for expressing all of this. So things like the WebGL object and your textures and all of that are just dynamic objects. You call the appropriate methods, you do your typecasts, you're good. And then things like your vertex buffers are just arrays. You just make sure that they're formats that if you were using desktop OpenGL or Direct3D, you make sure you could pass them to the video driver, and the compiler and the libraries are able to do the rest. And that approach works out in most cases. You occasionally run into kind of corners where you just have to go, now I've got to do something special. But for the most part, that approach just works great.
Mm-hmm. So these are samples, but I'm assuming that a scapegoat, as kind of like the canonical example, is quite a bit larger. How much code are we talking about?
I don't know roughly how many lines of code a scapegoat itself is. I can get you a quick number on how big the compiled site is. Let's see here.
I'm assuming that we're looking at thousands, not hundreds.
I think it might be close to, it's probably in the 10,000s, if not hundreds of thousands range. The compiled JavaScript for it is about 40 megabytes when it hasn't been compressed.
Oh my.
That's including a lot of the type information the compiler spits out, because one of the important things, actually, a lot of real applications use it, is reflection. So I produce all of the information you need to reflect on the standard library in your code. So that actually adds a lot of weight to your executable. But beyond that, just like there's also a lot of code in that game. It's a very old code base with a lot of subsystems. Like it has a full level editor, has a physics simulator and all of that.
So that's interesting. So you're saying that if I, for whatever reason, wanted to be in my C# code reflecting on, I don't know, something in system.txt, you're saying that that can come all the way over?
Yeah, the compiler pulls over all of the type information for everything you use so that you have it. And there's a third-party contribution from some open source developers that does dead code elimination and other sorts of optimizations on that. But the default case is all of that's there. It'll just work for the vast majority of cases. So you can create delegates. You can construct objects based on a type at runtime. You can do all of that.
Mm-hmm. And so there is a weight to that. Like of that 40 megs, some percentage that's measurable is maybe stuff we don't need. And then, like you said, you might strip that out later.
Yeah, the vast majority is actually.
Oh, so you're arguably kind of bringing down a JavaScript representation of the base class libraries of BCL just in case someone might use it without inspecting that they are using it.
Yes.
Which is an interesting other question, thinking about resources, because you're bringing the PNGs and the audio over, you said as well. Mm-hmm. If the person who was writing the C# was maybe loading those resources in an inappropriate way, doing it, not embedding it in the project, but rather loading it dynamically, you wouldn't see that, and then you might miss that resource.
Yeah, that's correct. If you're just using the file system directly, you have to give the compiler a little help. But it emulates the .NET file system at a reasonable level so that if you give it a little help in terms of configuration and providing the appropriate files next to the generated JavaScript, it'll still work. So a scapegoat, for example, didn't use resources for its level data. It just put those in the game folder. And that came over just fine. I just had to kind of feed in a little configuration to tell the browser, here's where the level files are. Here's what the file layout needs to look like so that saves will go into the right place and so on. Mm-hmm.
Which brings me actually to my next question. How much was it a push a button and a full game happened? And I assume that's the intent. And how much massaging, hinting, configuration did you need to make a scapegoat really happen?
So for most of the smaller projects, it is pretty close to just automatic. For a scapegoat and for Soulcaster, in both cases, I found a good number of compiler bugs during the process of getting it all the way. But the games in both cases were up and running to the title screen in about an hour. And the final game, browser version of a scapegoat, has maybe 3,000 lines of total changes to the game code, and almost all of those were browser integration. I made optimizations in a couple of places so that it would be faster on both platforms and be playable in the browser. But other than that, I didn't have to make any code changes.
Mm-hmm. Where do you see other JavaScript to, IL JavaScript bridges, like people always talk about Script Sharp, which was written by a Microsoft employee, and then SharpKit to a lesser extent. Where do you see those fitting into a world like this?
I feel like those definitely occupy an interesting space. It sort of sits alongside CoffeeScript, where people want to leverage a lot of their existing knowledge and tool set to build browser-specific applications from scratch. And that allows them to do some really interesting things that you couldn't necessarily do if you're just taking an existing application and porting it. Mm-hmm. And I think that provides a nice sort of counterpart to the approach that I use and that Inscription uses, where it's about taking an application you've already built. They kind of complement each other really well. For example, if you're using WebGL, you're probably using something like 3.js, a nice convenience library that wraps everything. You wouldn't write something like that in Inscription or in JSIL. You'd probably write it from scratch in a language that is designed specifically for the web, whether it's TypeScript or CoffeeScript or Script Sharp. So it's nice to have kind of both of those spaces occupied.
Mm-hmm. But it seems like if I'm a game developer, I should spend time looking at JSIL to get my games in more locations. And if maybe I were doing like an MVC project, I might look at Script Sharp.
That would be my advice. I think it's important to understand what the trade-offs are and whether you want to invest the energy in having that sort of portability or whether you just want to pick a set of tools and tune everything for that and just be okay with the limitations that come with it.
Mm-hmm. The getting started instructions are pretty fantastic. You basically, you build it and you bring it down and then you run JSIL C, the compiler, on your app. Mm-hmm. And then the best part is marvel at the convoluted error messages. Is that pretty much it? You run it and you see if it works and then you massage it and you run it again.
Yeah, pretty much. That getting started guide is also sort of a wink and a nod that this is very strongly a developer tool for developers. At some point, it will be sort of a retail-ready packaged product with Visual Studio integration and such things, but it's always been such a difficult thing to get right that I want to make it clear and upfront that this is something that requires you to understand your application and the browser, and then I will do everything in my power to make it easy for you from there, but kind of here be dragons. Eventually that message will probably get replaced with something less scary.
I gotcha. So if someone is coming in here and, they have their full game and they're like, it didn't work, that's probably not who we want as a customer right now. This is a development tool, but it seems like
they're a great customer as long as they're okay with filing bug reports and, either being willing to do investigation and get things working or just accept that, like, it's not working yet, I'll come back later.
So it's a great community to join, but it's not a product yet.
That's what I would say, yes.
Yeah. But it sounds like your plans for the future, really one's mind boggles, with the way Visual Studio is opening up. They've got Node in Visual Studio and Python and all these other languages. One could see JavaScript, as a target integrated within an XNA application that you're running and developing, and you hit build and you dynamically generate both of them and have your automated tests run on both targets, the JavaScript and the native.
Yeah, that reality is actually kind of already there. It just requires a lot of manual setup. One of the examples does just build the JavaScript out of Visual Studio when you hit build, and then you just have to open it in the browser. Mm-hmm. And there is a third-party group of open source developers out there who are building a full WPF implementation for the browser on top of this stack. And they have Visual Studio integration they're working on that, as far as I know, provides a lot of that outside of the box. So there's a lot of pieces out there that prove that you could build that whole experience. It's just a matter of getting there and having it done, I think.
Sometimes I think people who are maybe more, I would maybe say kind of more straight and narrow corporate developers might look at a project like this and maybe be afraid to share this with their boss because they say, well, that doesn't really come from Microsoft, or that's just it's too impossible to exist. How is this a thing? Like you're describing, a possible WPF implementation in a browser. That's mind blowing, but I'm seeing more and more amazing stuff being done where I always talk about Lego pieces. Like, you saw like, well, this Lego piece, it would probably snap into that Lego piece if I just pushed hard enough and wrote a little massaging code in the middle. What do you say to the straight and narrow people who are like, I don't want to touch this because it's too much?
It's important, I think, as a developer, especially when you're maturing and growing and you're educating your teammates. You want to destroy fear every time you have the opportunity. Fear is this really natural response you have to everything difficult in software engineering.
Yep.
And as you get more experience, it becomes possible to get rid of it and know, okay, out of all of this stuff, all of it is possible. It's just a question of how hard is it? How much am I going to regret it? So with this sort of thing, really, if you're an enterprise developer, you're right to be afraid of the risk that comes with it. Mm-hmm. You just need to be willing to go, okay, now I need to understand how much of this fear is well-founded. Out of these consequences, which ones am I willing to tolerate? Is this sort of a trade-off that I'm willing to make for my project? And I think for many projects, it's not the right trade-off. You want something that's more stable and has a rigid release schedule and paid support. And for other projects, you're quite happy to just adopt third-party libraries, contribute fixes to upstream, and build on it. Sort of like the distinction between using the Microsoft ASP.NET stack or using something like Mono's stack or using Node.js. They're kind of different spheres, but enterprises can use both. It's just a matter of whether it's the right fit for you and your team.
Mm-hmm. I think that's really, really well said. What do you think about the future now that last week they open sourced and they're starting to open source all this stuff and Roslin's open source? Does that make your life easier? Does that make you plug in even better?
At present, it doesn't really affect anything, but it certainly, I think number one, it just kind of cements .NET's status as sort of the future of this particular type of technology. It's never going to replace LLVM, but it at this point does everything that the JVM was promised to do while offering languages and tools that people like a lot better. And it is now firmly under the control of the community and not just Microsoft. So you have a lot more confidence that it's not going to vanish without notice. And the open source certainly makes it easier to support everything from the side of a compiler. Like it means that in the near future, I will not have to write my own runtime library. I can just compile theirs. That will be a huge boon. So it definitely means good things for the future of JSIL, and I think also compilers like ScriptSharp will be able to adopt more of that official library.
Yeah, it does bring a question of how many different things where you could refactor your code by subtracting, because if you got the code for the base class library for the core runtime, then what could you just right now you're pulling the IL out and looking at the AST. Maybe you just compile straight across or whatever.
Yep. Something like that is always possible.
And is Scapegoat the biggest game that has been done, or are there any other games out there that you can mention that are using this, or are they secret?
I think there are some private projects that are bigger. There's one customer who has a rather large enterprise WPF application that they have working in the browser, actually using the Mono runtime library, but that's not at a state where it's actually kind of ready to put out in public. And likewise, there are a couple of games that are a bit larger. Scapegoat is a really good representative example, though.
Mm-hmm. And the last question I had is around performance. You're very creative online when you talk about it's just a labyrinth of landmines. You think you nailed it, and then some weird performance thing comes up. What kind of things do people see? Is it pixels on the screen, pushing pixels problems, or is it memory management problems?
Memory management is probably the worst one, just because I would say JavaScript does not have value types. That is the one thing that kneecaps you. In the same way that it is actually a real performance obstacle for Java, having value types and structs that live on the stack was a huge win in terms of the design of .NET, and it's not possible to express that in the browser right now. So JSIL does a lot to kind of mitigate the costs there, and in the future, JavaScript will probably adopt some improvements to fix that, but that is the one thing that causes the most performance issues, especially for XNA games, since they're tossing vectors and matrices around all over the place.
Very cool. This is a really exciting project, and I hope that more people learn about it.
Well, thank you very much for talking about it with me.
No, it's my pleasure. Katelyn Gadd is a freelance programmer and game designer, and you can follow her on Twitter, check out her website, and check out JSIL.org. This has been another episode of Hansel Minutes, and we'll see you again next week.